Hey there, and welcome to the It's All Good Mining and Repair channel. I'm Brian, your host, and today we're going to dive into a S17 Plus board that I'm kind of embarrassed to tell you what I did to this. So let me go ahead and flip over to the board, and I'll tell you as I go. Also, I've been making some changes to the stream setup. If you like the changes, if you think this helps to give a better view of the repair as it's going on, please make a comment down in the comments down below. Let me know. Let me know what you like. Let me know what you don't like, and I'll continue to work on improving the video feed for you. All right, so this is what I affectionately call repair board 03. Okay, 003. This is one of the earlier boards I started working on to repair, and well, I got it working. I actually got all of it working, and but I didn't put the heat sink on. So, like, if I grab this one, this happens to be a board 001. We'll get to this board another time, but this is the upgraded heat sink, and so I put the nuts on, and I stopped short of this, and I put it in the miner just like that. I set the hash rate really low. I set the frequency to 100. I bumped it up to 125. I kept my temperature limits really low, like 70 C. But I really hurt the board. What I was trying to do is I was trying to troubleshoot the temperature sensors. So it didn't work out. Since then, the board has been absolutely schizophrenic. Sometimes it'll go 65, then it won't go 65. So let's dive in. Let me get some things turned on. Okay, there we go. All right, so notice I'm running the voltage really low, 15.5 volts to the board. That keeps the board nice and cool while I'm troubleshooting. The tester down here, let's see if I can flip over to the bench only. Let's see, can you see that? Yeah, well, you can almost see it. So it actually says 13.73 volts. Here's the interesting thing. So right now I've got 65 chips, and that's good. Yeah, okay. So I'm gonna test the CI right here. CI is good. This board used to have problems at 46. Here's where it really gets neat. I can go over here to 59. I still got CI. I'm sorry, that's 55. No, 56. That's 56. Oh, here we go. Here, I'll move it in so you can see. So there's 56. It says good. If I go to the next one, which is going to be after 56, no dice. So there's something not happy about that chip for CI. Okay. Cool. All right. Now this is where if I switch over to BI or BO, so it's funny. My tester says BO. The screen shows BI. Or I'm sorry. Tester says BO, BI. The screen says BO. I check it here though. I got it okay. Right. So I'm checking here between 40 and 41. I come to 50, 50, 50, and 51. I got BO. I got BO. Take a shower, Brian. Okay, good. 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 Let's jump way over here. All right, it's just gonna jump over here. All right, I still got BO. Look at that. I got BO. That's good. Okay, let's jump all the way up here. I still got it. Come all the way down. Ah, look at that. I have it all the way through. This board actually has hope now. Oh, that's interesting. Oh, it turned off. Let's try it again. Okay, BI or BO, depending on what you're looking at. Okay. Okay. Okay, that's pretty good. All right, that's good. All right, I'm going to go all the way down here. Okay, I don't have it there. Don't have it there. Don't have it there. Not there. Okay, so CI stops after 56, and BI or BO, depending on what I'm looking at, same thing. It stops after 61. So since those two, I'm going to go ahead and I'm going to replace those chips. All right. Okay. So if we look, the mustache chip it's an original chip. Because I did actually take a sandpaper to this board. So that's an original chip. It's never been changed. Or if it has been changed, it was changed originally. And smiley face here. Ick. Man, I'm embarrassed. I'm embarrassed to show you guys this. Look at how crappy that solder job is. But you live, you learn. You keep doing this, you get better, right? Okay, let's fix that one first because it's my most embarrassing one. Hang on a second. See that? Yeah, you see that. So let me check my sheet real quick. I don't have a scene. What I'm gonna do, I've got a sheet. Or do I? Let me look. All right, so what is this? This happens to be a spreadsheet that I put together to kind of figure out what the heck is going on. And so if we go back, let's see, let's get back on the microscope. So what I want to look at here, smiley face. All right, so that's U96. It's upside down. So let's go look and see what U96. Now, the way I recorded it was by the actual socket ID, right? And I reference all the chips and or resistors and capacitors by the markings on the board. So that's U96. If we were to flip it upside down, I could see, so I can kind of get there, but I'm going to stretch my cable. So see, there you go, U96. Okay, cool. All right, so let's go back to my sheet. And I just go here to my sheet. And I do it. Okay, so cool. Now I've got that up. So this is the fun part. I'm going to go off of that and I'm going to look. Now everything's upside down on this one. Man, what a pain. Okay, so I just changed things around a little bit. And if we look now, what I've got is R945 and R956, which are both, if I go back to my sheet, right? So 945 and 956 are no resistors. So, okay, that's good. There we go. Okay. Does look like, based on the Okay, tone that down just a little bit so it's not blasting us off the screen. It does look like I've replaced this chip before because all the solder looks very fresh. I'm just going to touch up the solder. Okay, cool. Not really much work to have to be done on that pad. Compared to the last chip, that looks a lot better, huh? Okay. Hold it there for a little bit. Okay. As you can see, I just set the air gun, lay it in my lap. It's blowing off in an area that's not blowing into anything hot or anything where the heat would cause a problem. That's the new chip or the replacement chip versus the old chip. Definitely looks better. We get a little bit of alcohol. As always, you want to make sure that you don't just start wiping things around before the solder has solidified on those resistors. Otherwise, your simple chip repair will turn into a chip nightmare. Okay, that lets me know that I replaced that chip. This go around, i.e., since I cooked the board. Something tells me we're gonna have to clean this one up. But we will see. We will see. All right, looks like we have a little bit of bubble. This should actually be ready to go. No, it's not. Interesting. Okay, well, that's not my primary task. So I can fix it later. Oh, yeah. That is definitely needing to be cleaned up. All right. So, when I clean these up, a little bit of my MG chemicals, no clean flux. That's 8341. Get solder wick. Now I can switch over to my Amtex flux, or I can go back to the MG chemicals. It doesn't really matter. I'm almost out of the MG chemicals, and I'm waiting to get some more. And I have this Amtech flux that I bought as a trial. Just it's personal preference, but I'm not going to go back. I'm not going to get another. I'm not going to get any more Amtech. At least not the V2, because the 559 V2 is not formulated to work with no lead boards. So when you're removing and cleaning up chips, they've got lead on them. or I'm sorry, they're lead free, because that's just the way everything is, right? Oh. Dab solder there for that one. Little dab there. Okay, cool. I'll just dump the rest if I've got any left there. Okay, cool. Solder turned a little brown, but it's still good. I'll give it a little bit more to it. That was so good, except for I bumped it. Oh well, it's okay. Can still fix it. Okay. Let's give it a tap. I want to make sure that I get it to lie flat. It doesn't feel like it's all the way in. Like you can see these two. Alright, I feel like I'm going to have an embarrassing one here. So you know what I'm going to do? I'm going to take it off. I dropped it. When I dropped it like that, it messed it up. So no big deal. Let's flux it. And we'll put some extra solder on there. Try again. Alright, no big deal. Let's fix that real quick. Oh, actually, let me get a chip. Oh yeah, and you can see the capacitor down there. Tell you what, while I'm heating things up, we can move that back into place as soon as the board gets nice and melty. Surface tension is your friend. Okay. Good, good, good. Look at all those pretty shiny solders. Okay, that's 61. I have trouble marking writing normal. Writing sideways is really fun. All right, turn some fan on. Let's get this thing cooled off so I can get it onto the tester. All right, 54 ohms there, 55 ohms somewhere in there, 62 ohms. Good. Let's see what we get. 65 instantly. Oh, darn it. Why is it doing that? So there was a firmware update. Hold on a second. Let me come over here to overhead for you. So there was a firmware update just recently, and since that firmware update, it has not been connecting good. Or the application for the Windows is not connecting good. Okay, that's interesting. So I replaced 56. Now we got past, oh, there it is. Now we got past 56. And we're now, there we go. Okay, so let's check our signals. Because that's why we replaced. Hey, straighten up. All right, turn off the map hold. Okay. Are you done? Okay, I want to check the BI real quick. Check the BI right here. See, no BI now. Okay, the other point to make is that we're actually looking at this higher voltage. So let's go ahead and stop it. Turn it on down. This is where I was seeing the BI pass. So let's crank it back up. All right, so I'm gonna come over here. I'm gonna jumper. Get the test jumpers. Okay. Jump 15. Nice and stable. $16. Nice and stable. $17. Of course, I'm not going to go after that, right? I'm not going to go 18. Oh, that's fun. I got to 18. $19. $20. Now remember, when you're jumping these, you go to the RO, and when you transition from one domain to the next, you don't go to the power for the 1.8 that you left. That won't work. Go to the next one. Go to the 1.8 that you were going to. 30 jumps. Oh, that's interesting. 40 doesn't jump. So it looks like we have two problems. We have a problem with 31, and we may have a problem with 18. So let's see if we can fix those two next. Actually, I'm going to do 31 first. throw that Q-tip away and get another Q-tip. All right, clean. I'm gonna desolder this, so because I'm using, I think that might still be some old lead-free solder, so I'm using my chemical. I'm just cleaning it up because I did go from one solder to the other, or so. Okay, now I'm gonna grab my Amtech because I got more of it. Turn around sideways here. I'll turn the camera. Yeah, there you go. There's entirely too much flux on this one. I can tell I'm going to fight it, but before we get too far into it, okay. I'll rush and do that with a paper towel. Crazy, right? So. Okay. Sometimes the pad, chip pad, will be kind of recessed in with the solder mask, and when that happens, it's easier to just drop the chip down into this. It almost feels like it's a dedicated socket at that point. But I feel like this one's gonna fight, but it's starting to smoke, so we're getting really close. Yeah, there we go. All the little bitty BBs. That's what I wanted. That's how you know it's a good one. Oh, man. There you go. Chip 31 has been replaced. If you're enjoying this content, be sure to smash that like button. And since 99% of my viewers don't actually aren't subscribed, give that subscribe button a smash and click the notification bell, and you'll be notified when I post a video or go live. All right, we're 15 volts. I got 31. Sticky. Yeah. All right, here we go. Boom. 65. That may have been the squirrely chip. Like I said though earlier, is this board got All right, somewhere around 54. That's if you look up there. Okay, now it's 52. Hell, it doesn't know. All right, let's take that. I'm gonna go right after 51. I'm gonna jump her. See if I can settle this thing down. See, I can't get it to settle down. That tells me it's probably somewhere over here. That's fun. Okay. Let's just for grins, I want to see what's going on. I'm going to stop the low voltage, crank up the voltage to 18.5. I want to see what it registers. 65 instantly. Okay, fun. I want to go to run a temp test. All right, and so this is where we still are. See, we're foobarred here. We got no temps. Then we got some temps. Hey, that's, yeah. So this is the problem with this board. The temps just are wacky. It looks like to me. No, then you lose them. I think the reason why the temps go wonky is because of the signal is not right. So, because the way I understand it is let's go over here to the overhead real quick. I could be wrong on this. The way I understand, there is there's a temperature sensor, like a T2H little sensor on the backside that connects to this chip. There's another one so this is number 1, number 2, number 3, and number 4. Okay. And so when there's weirdness in the signal flow, then that information can't get back to the EEPROM or the PIC chip area, and so it just doesn't get sent back properly. That seems to be where we are. So I'm going to end this video. Thanks for watching. I'll update you in the next video to let you know what I'm doing. I won't just say, oh, it's fixed. I'll show you actually what I've done to fix it. So stick around for that. Remember, this is board 003. So thanks for watching. Have a great day. I need a tagline. If you got a great tagline, leave it down in the comments for me. I need something. Thanks for watching. Have a great day.